In this video, we're going to look at the concept of the normal distribution, and I've got a diagram here which shows you just a normal shaped bell curve. And what we've got here, either side of this thing over here, so we've got one standard deviation either side of what we call our mean value. So our mean value is our average value, and you notice the shape of this diagram is symmetric about that. So when we're looking at that, so one standard deviation over here, we've got two standard deviations to this point here, and three standard deviations. Now, there is a rule which sort of talks about the area bound by these things. Okay, so within one standard deviation we have, or should have from our sample, 68.26% of our population lies within one standard deviation. So that would be 34 and 0.13% either side of the mean. And then within two standard deviations, 95.44% of the population lies within two standard deviations, and within three standard deviations, 99.74% of our population falls in that range. Now, in terms of a normal distribution, any data, if you've got a sample which is large enough, will actually be a normal distribution. So if we start looking at an example over here, which I've got set up for you, we've got a histogram here. So if I just start with a smaller sample of 1,000, right, and I do a sample for that, you can see the sample that I'm getting there varies quite a lot. Okay, but it shows sort of that same sort of bell-shaped curve. Now, if I go to the extreme case over here, where I've got 5,000 bits of data there, right, you can see that the graph itself becomes more normally distributed each time I get a new sample. So it's not varying as much as it is. Now, if I just go to a smaller number of intervals, I can play around with that. If I go to my 1,000, right, you can see that when we do get a sample, it's not too bad. Alright, so you're getting an idea that it will vary a bit. When I go to 5,000 though, my sample is a lot more normally distributed all the time, a lot more consistent with that. So the more data you do, the closer you're going to get to a normal distribution. That's really the key concept that we want to look at here. Alright, let's go back to our document. So that's what you need to know. Now there'll be a question in the test which will require you to use this information. Alright, if you use this information, then you could have to use this diagram. So you might get a blank one of these and actually have to represent that. So I'd like to go through an example a little bit like that. And it's out of your textbook. So it's example number 2. So the mean distribution is 50. Normal distribution is 50 with a standard deviation of 6. What is the probability that a random selected value lies between 44 and 50? Well, first of all, with this diagram, what you need to do is you need to better mark these things on here. So if I'm looking at my mean value, it's 50. Right, if I go one standard deviation this side, that's going to be 44. Okay, two standard deviations over here is going to be 38. And then I've got three standard deviations over here, and that's going to be 32. If I go the other side, one standard deviation is going to be 56. Two standard deviations is going to be 62. And three standard deviations is going to be 68. If you haven't worked it out yet, when we start talking about statistics, we're talking really about probability. The probability that if I pick someone at random, they're going to fall in this area here. Now, the area under this whole curve is in fact 100%, right, which is going to be like 1 in terms of a value. So we're going to be getting a value which is a fraction of 1, and we can convert that to a percentage. So if I was looking at this first one, so the chances that it lies between 44 and 56, then we'd be looking at this region here. Alright, so we're looking at this region here, right, and so therefore, in terms of if we go to our particular value up there, we could say, well, we know the area of that's going to be 68.26%. So for number A, we know that and it's talking about probability, so we should put that. So the terminology you do and we're talking about x being greater than 44 and less than 56, then we can say that's got a 68.26% chance of that happening. Alright, so that's what we can get from our graph. We don't need to actually do any calculations there. Alright, so we extend that on to the next part, part B. What's the probability it lies between 38 and 62? Well, I can just extend my thing over here. So I'm looking at the area now for this region. Okay, and so therefore we're looking at 2 standard deviations for that. Alright, so you get the idea? So 2 standard deviations we know in terms of our diagram, that's 95.44%. So again, the setting out would be probability that lies between 38 and 62. I'll get rid of that. Alright, and then we can just write down our percentage, which is 95.44%. Now, it could be represented, by the way, as 0.86826, or it could be represented as 9544. So both of those mean the same thing. So one's a decimal, one's a percentage. Now, if I was looking for between 44 and 64, that would mean that I'm actually looking for this region here, between 44 and 62. So therefore, what I need to consider is the regions that I've got there. So for that, the probability of 44 to 62, so that's going to be equal to, well, I could just add up these particular values if you like. So it's going to be 34%, 2 lots of 34%, so that's going to be 68.26% plus 13.59%. Okay, so that's what I'll need to do. So I could go, that's equal to 68.26% plus 13 point, now I just have to remember what it was, 13.59%. Now, there's no problems in a test. I would certainly have this on your cheat sheet for you, so you'd have that in front of you. No need to remember it, just to know how to use that. So I just have to add those two things together. That's going to give me 81.781%. Okay, so that's my probability of doing that. If I ask these other questions, I won't actually do them, but I'll just show you what the area that you need to do. If it's less than 38%, so then what you're going to have to do, less than 38%, is you'll just be looking at this area here. Okay, so you've got that region there, and then you've got this little region in here. So that's less than 38%. So that would be the addition of 2.15 plus 0.13. So for that one there, it's going to be 2.28%. All right. So for part D, probability, well, I might as well do it. X is less than 38. That's equal to 2.15 plus 0.13 equals 2.28% chance. So it's not very likely that that's going to occur. If I was looking for a greater than 56, all right, then I'd be looking at this region here, all right, going greater there, all right. So, and I just have to add, obviously, these particular values. I have to add 13.59%, 2.14% and 0.13%, and that will be my particular area. Now, there's a couple of questions to have a go at doing. This would be a recommended or fairly expected question in an exam or in a test, so I'm guaranteeing you're going to get one of these in your test, but most likely in your exam as well. So know this distribution table. I'm going to show you a way that we can actually work on this next video when it doesn't fall on those lines exactly, and to do that we're going to need to use our graphics calculator. So look forward to going through that with you. Have a go at those questions, and if you need some help, make sure you catch up with me in class.